Well, this is a video provided for you so that you can prepare for a retake on your rock and fossil record test. And so this test has 4 standards on it, and you only have to retake the standards that you didn't earn a 4 on. And of course, if you earned a 3, it's really up to you if you want to retake it. But so you really don't need to watch this full portion, depending on the full video, depending on what you need to retake. So the first standard was standard 6 about relative dating. And I wanted to go over that with you. So the first question there says that the principle of superposition states younger rocks are on top of old rock layers. That is for sure true. And number 2 is also true that relative dating is putting events in order. So the superposition, that's what it does. It says younger above older, and it is for sure a relative dating technique. Number 3, the answer is original horizontality. That's the principle that explains in the first place that rock layers are deposited flat. Now, when we were building our geologic columns, we started to understand what an unconformity is. In one word, you would say it's a gap, and that's the right answer to number 4. It's an area where something's been eroded away, and it makes you go, I wonder what used to be there. And then number 5, the geologic columns that we built, and the geologic columns themselves are tools that scientists use to answer the question, what used to be there? So number 5 should be C, geologic column. We learned about some different disruptions to rock layers, and the answer to number 6 is a fault line. A fault line is when there's a crack in between rock layers, a break. And then number 7 is a B, intrusion. That's when magma sneaks in like an intruder and cools. And then number 8 is false. Tilting is not when rock layers are bent. That's folding. A tilt is a slant, but the layers are still in a straight line. Now, question number 10. Oh, excuse me, I misspoke. Question number 9, the only word I'm really scoring for is order. Relative dating techniques show order. Please don't say that they are guesses. Please don't say that they are estimates. Relative dating techniques just don't use numbers, but they aren't guesses. They just attempt to put things in order. Okay, now question 10. So question 10 was the first diagram that you had to interpret. And so you can see here that there are actually 4 rock layers, keeping in mind the road is not a rock layer. So how do we put these in order from oldest to youngest? And so I always start oldest and work up. The right answer here is limestone, then shale, then sandstone, then igneous. Now let's look back at why. So I think that the trickiest part of this is the igneous. And so you have to think, well, that igneous, that's an intrusion where magma snuck in and cooled. So you have to apply the principle of cross-cutting here, meaning that the intrusion has to be youngest because it cuts through all 3 of those layers. Another way to think of it is those 3 rock layers had to exist in order to get cut through. So how did we know the oldest layer? Because it's on the bottom, that's the principle of superposition. But again, the youngest we know because of cross-cutting. And the idea is that it cuts through the other layers, so those other layers had to exist first. Okay, now you had another diagram to interpret, and this one had 3 layers to it. And again, you were putting them in order and understanding how, or telling me that you understood the oldest and the youngest rock. Now, this one has peanuts in it. What I mean by that is these 2 little nuggets here, those rocks are actually part of C. And so the principle of inclusion says this, that the inclusion has to be older than what surrounds it. And the reasoning is these had to exist in order to get surrounded. So what we actually have here is a layer of sedimentary rock and 2 intrusions. And so notice that the intrusion here, B, actually cuts through both A and C. So that tells us it's the youngest. And so here's how your order should look. The youngest was B, A, and C. Now, how did we know the oldest? That's the principle of inclusions. It was included in A, so it had to, C was included in A, so it had to exist first to get surrounded. We know B is the youngest because it cuts through the other 2 layers. Okay, now the final set of questions for the relative dating standard, you used these images. And the thing with this is you were creating a geologic column for an area, but it was a little easier than the one in class because there were no unconformities, no eroded away gaps, but you still had to do some lining up. And so you probably noticed right away that there was only one layer that was in common between these three rock outcroppings from the same general area. And that layer is conglomerate, which is a coarse grained sedimentary rock. That's why it looks like it's a big chunked in the diagram. And so when I lined up those conglomerate layers, you see how I've done that? Then I can get the ideal sequence of rocks and fossils in the area if nothing had ever been disrupted. And so when we look then at what's the oldest overall layer, we look to the bottom. So the oldest would be here with this gray sandstone, and the youngest overall would be the glacial deposits that you see at the top of the sequence. Now, let's get to the questions. Question number 12, I asked you, what's the only rock layer in common? That would be sea conglomerate. The oldest was gray sandstone, and the youngest on top of everything were the glacial deposits. That just means rocks that were left from a glacier. But then I ask you an interesting question about shale. I tell you that shale appears in three different places in the geologic column. So let's look at it. Here's some shale, and that's the same layer. Then I see another layer of shale, and then another layer of shale. So how am I supposed to be able to tell those apart? Well, notice that this one says shale containing trilobite fossils. This says black shale, and this just says shale, which is typically gray, I'm assuming. And the two best answers here are the fossil record, or you could just say whether it has fossils or not, and the color. If you also mentioned that the positioning within the column tells us them apart, that would be okay too. So if you need to retake standard 6, that's the part you need to restudy. Now I'm moving on to standard 7 about how absolute dating techniques work. And so number 12 there, oh, I'm sorry, those are misnumbered, I just noticed. So this should actually be number 16. Number 16, the answer is B, neutrons. And the question asks us what isotopes are, and isotopes are the same element, they just have different numbers of neutrons. Now, question number 17 asks about carbon and which form is the stable isotope of carbon. That is for sure carbon 12. Question number 18 is true. Carbon dating is a way to find the absolute age. Remembering this, absolute is exact. Number 19, a fossil will always have some carbon-14 in it. That is false. Eventually, think of it this way, all the red chips will be turned to yellow. Now we got into a little bit of math of understanding half-lives. And question 20 asks, what percent of carbon-14 will be left after a fossil has been through 2 half-lives? And the correct answer to that is 25%. Here's how you have to think of it. One half-life cuts it in half to 50% of the original 100% that was there. And then the second half-life goes from 50 to 25%. Now, knowing that a half-life for carbon-14 is 5,730 years, question number 21 asks you, how old would that fossil be if a scientist found it and it had exactly 25% of its original carbon-14? And the absolute exact age would be 11,460. Okay, so question number, oh yeah, I wanted to show you this too. So when I asked you about carbon-12 versus carbon-14, when you look at this with me, this side is the carbon-14, this side is the carbon-12. And notice they both have 6 red protons, but the carbon-14 has 8 black neutrons instead of 6. That's what makes it unstable. Okay, so now let's get to question number 22. Question number 22 says, pretend that a scientist analyzed a fossil and you found that it had most of its carbon-14 left. What does it tell you? Well, see, here's the thing, folks. Most, to me, means more than half. So it's like saying, oh gosh, that fossil hasn't even been around for one half-life. So it tells you that it is young. And then the idea is that the older the fossil is, the more the carbon-14 will be reduced. Okay, so now continuing on with standard 7, you had this graph to analyze. So So this is showing the radioactive decay, which just means the breakdown of potassium 40. Potassium 40 is a radioactive unstable form of potassium, just like carbon 14 is an unstable form of carbon. And so there are two questions that go with this. Question number 23 asks you, how long is one half-life for potassium 40? So here's what you have to do. You have to say, whoop, right there is when there's half of it left. That's one half-life. You come down then to the x-axis and you notice that it's in between 1 and 2 billion years, but it's definitely closer to the 1 than the 2. So for question, sorry about all of this mistake here. For question number 23, you should be saying 1.2 billion years. And then also this one here is question 24 on your work. So why would a scientist choose potassium 40 over carbon 14? The really key phrase I'm looking for is it has a long half-life. So you can use it to find the age of a rock or fossil if it's run out of carbon 14. So it's not going to run out of potassium 40 because it breaks down so much more slowly. Okay, so that ended standard number 8. Excuse me, I misspoke. Standard number 7 about absolute dating. And now we move on to standard number 8, which is about finding trends in the geologic timescale. And this standard only had 4 questions with it. So which is the shortest period or shortest time period, an aeon, era, or period? That's for sure period, because eons get split into eras like Cenozoic, Mesozoic, and Paleozoic. And then the eras get split into periods from there. Scientists agree that the Earth is not in the millions, but billions, 4.6 billion years old. And when you picture that football field in your mind, I hope that you're seeing most living creatures and their appearance in the fossil record near the today end zone, and also that you are remembering a trend in complexity. So this would be question 25, 26, 27, and 28. So for question 28, the trend in complexity is that simple creatures appeared longer ago and more complex ones. When I say more complex, think lasagna over mac and cheese. More complex creatures like humans appeared really close to the today end zone really recently. So that's it for standard 8. Now standard 9 is about the fossil record. And so if you need to retake that standard, you should continue watching to study. Okay, so question number 29 asks you about the type of rock that's going to contain fossils, and it's for sure going to be sedimentary. Here's why. Fossils are basically chunks that can be cemented in a sedimentary rock. Now, question number 30 is generally a hard question for students. You have to remember that a trace fossil is evidence of activity, but not the real part. So a shell is a real part, making it not a trace fossil. Okay, now question 31 asks you to pick 6 ways, or excuse me, from the 6 ways, it asks you to pick 3 ways that fossils can form. And I do not care which ones you pick, but here's our list. And this happens to be in order from most common to most rare. In sedimentary rocks, mineral replacement, that's like petrified wood or the famous coprolite. Minerals go in and fill in the cell walls, and you end up getting a rock that is an exact replica of the creature or the poo. And then in amber, which is tree sap, tar pits, mummification, which means drying out, and also being frozen. Again, you only have to pick 3 of those on your retake. So now we get to question number 32. Question number 32 says that you find, oh gosh, did I mess this up? I just might have accidentally deleted. Oh, here we go. Sorry. I skipped ahead too much. So question number 32 says, in your backyard, you find a rock that has a brachiopod in it, which means it's like a shelled creature. What does this tell you about Ohio's past environment? And it means that your backyard was once an ocean. No joke there. Okay, so now we get to this. So here was a diagram for you to analyze, and this was the last set of questions on the test. This is actually question number 33. And so it asks you to look at layer B. And if you could travel back and observe Earth's surface at the time that layer F and layer B were deposited. So what would it be like? Okay, so you really have to look at the fossils. So when you find layer B, you notice that you have seashells, a fish fossil, a, um, an ammonite, which is like a nautiloid. And then when you look at layer F, you see footprints and you also see plant fossils. So here's what you should conclude. The time that layer B was deposited, the surface was an ocean. And you know this because you see fish and shelled creatures. When layer F was deposited, however, it was not an ocean environment. I know this because I see prints in land plants, and dinosaurs lived on land. And it does tell us in that key that those prints belong to a dinosaur. So the present is the key to the past. The fossils we see in the present in a layer tells us about the past surface.